Hi, Year 3. It's maths for Tuesday, the 2nd of February today. Mrs. Silverthorne here. Okay, let's jump in. Something a little bit different today. This should be a reminder of some learning that you did when you were in Year 2. So have a little look at all of these coins. Can you write the name of each of these coins in numbers and in words? Pause the video here and give it a go. Okay, so let's have a look and see how you got on. This one, it was 1 penny or 1p. This one, did you recognize it? It's a 2p or 2 pence. This one is the smallest coin in Britain and it is a 5p or a 5 pence. Another silver one here. It's a 10p or a 10 pence. This one, I don't know why I tend to like these coins better. I think it's just, you know, they have an interesting shape. They're not just round, are they? So this one is a 20p or a 20 pence. This one, 50p or 50 pence. This one is £1. And this one is £2. So tick off the ones you got correct and let's move on. Okay, so for our learning today, we're going to look at finding some combinations. So you might be thinking, Mrs. Silverthorne, we're doing multiplication and division. What has that got to do with combinations? Well, let me show you. Jack has 3 t-shirts and 4 pairs of trousers. What combinations of outfits could he wear? Well, this is an interesting one because we need to think about how do we know that we found all of the ways Jack could wear these combinations of t-shirts and trousers? One way could be, well, let's line them up. So he could have a blue t-shirt and blue jeans. He could have a blue t-shirt and dark blue jeans. He could have a blue t-shirt and orange jeans. He could have a blue t-shirt and green jeans. Okay, well, that would be all the combinations with the blue t-shirt, wouldn't it? But we haven't looked at wearing the green t-shirt with any of these trousers yet, or at looking at the red. So let's have a little look. So for the green t-shirt, he could wear the blue jeans, the dark blue jeans, the orange jeans, and the green jeans. Well, there we go. So surely we must have got all those combinations now. Nope, nope. We need to look at all of those jeans with the red. So we could have the blue jeans. We could have the dark blue jeans. We could have the orange jeans. And we could have the green jeans. So how many combinations was that? Well, that's where it gets tricky, isn't it? Because we've gone through that quite systematically. And I can't think of any other way of finding out how we know all the other ways. But how many combinations of outfits could he wear? I wasn't counting as I did it because I was trying really hard to be logical. Okay, so let's have a little look and see what could help us here. Okay, so with those 3 t-shirts and 4 pairs of trousers, what we could do is we could use a table to help us. So I'm thinking about all the ways I think, there we go, Jack could wear the blue t-shirt with these 4 different pairs of trousers. So he could wear a blue t-shirt and blue trousers. He could wear a blue t-shirt and dark blue trousers. He could wear a blue t-shirt with orange trousers. And he could wear a blue t-shirt with green trousers. Okay, well, that's quite good then, isn't it? Because I suppose if you look at it this way, I cannot possibly find any other ways that Jack could wear his blue t-shirt. I'm just going to move this one up here because we're going to try the same thing for the green t-shirt. So that would be it, isn't it? There's 4 ways he could wear the blue t-shirt and trousers combination. Let's look at the green t-shirt. So what if he wears a green t-shirt? And I'm going to be logical, so I'm doing this in exactly the same order as I did before. So the green t-shirt, blue trousers. Green t-shirt, dark blue trousers. Green t-shirt, orange trousers. green t-shirt, green trousers. Okay, so that's another 4 there, isn't it? Another 4 combinations. Let's try it with the red t-shirt this time. So red t-shirt, again, I'm doing it in the same order. So blue, dark blue, orange, green, so that then it's nice and logical and it follows a sequence. So red t-shirt, blue trousers, red t-shirt, dark blue trousers, red t-shirt, orange trousers, red t-shirt, green trousers. Now I've got no more t-shirts left and I've tried each of these t-shirts on with each of these pairs of trousers. I have found all of the ways possible it would be to wear trousers and t-shirts with these combinations. And I wonder if you noticed what I noticed. There are 4 different combinations. There we go. To go with each of the colored t-shirts. So there's 3 different colored t-shirts and 4, oh, I've joined that in there, and 4 pairs of trousers. And then there are 4 options for each colored t-shirt. Okay, so let's look at how many combinations there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 combinations. Okay, now when we do that, that's fine, but it takes a long time. So we could show this as 4 add 4 add 4 equals 12. And then we've got those 4 combinations. We can spot a calculation pattern there, but it's much more efficient to do 3 times 4 equals 12, because that's what we've got here, isn't it? Is 3 lots of 4. Okay, and we counted up the 12 different combinations. Okay, let's have a look at something slightly different. Okay, Lexi has these cards. She chooses 1 shape and 1 number. What are the different combinations she could choose? Now, earlier on, I put these into their different combinations. So square and a number, square, different number, square, different number. And I did this for all of them. I found all of the combinations, but do you know what I found? This took me a long time. Okay, it wasn't the most efficient method to working this out. So what's a different way that we could have done it? Well, a different way we could have done it is we could have thought, okay, for each shape card, there are 3 different options we could have had. And that's how we've ended up with 3 combinations here. But I don't only have 1 shape card to choose from. I have got 4 shape cards. So what I could be thinking of instead is the number of shape cards multiplied by the number of number cards. So there are 4 shape cards, and I could multiply this by the number of number cards. And there's 1, 2, 3 of them. And then I could use my times tables there to help me work that out. And it would give me an answer of 12. So let's just get this into some sentence stems just to make sure that we've really understood this. There are 4 different shape options. So 1, 2, 3, 4. There are 3 different number options. So 1, 2, 3. So 3 cards with numbers on. I can do 3 times 4 to find the amount of combinations there are. So I can use multiplication to help me work out combinations. Okay, let's move on. So Dora is making ice creams. She has 4 flavors and 3 toppings. Dora chooses a flavor and a topping. And I want you to see if you can have a go at completing the table to show the combinations. So for example, so at the moment, we've already done all of the chocolate ones because we've got the topping, the flavors up here. So chocolate, vanilla, mint, and strawberry, and then 3 different choices for toppings. So here, Dora's already chosen a chocolate and tried it out with each 3 of the toppings. So that's the 3 combinations there. But I'm going to choose vanilla. There we go. And then I would need it to go with each of these toppings. So again, I'm going to be systematic. So nuts. There we go. And then vanilla and chocolate chip. Move you over there. There we go. And then vanilla with the last option, which is sprinkles. Now, what you need to do is to see if you can fill in the rest of the tables. Pause the video here and see if you can work it out. Okay, how did you get on? So hopefully it went something like this. You then looked at the next flavor, which is mint. There we go. And then we thought about mint with each of these 3 toppings as a combination. So mint and nuts. There we go. Then mint and chocolate chips. This is making me really, really want to have some ice cream. And I'm not even the biggest ice cream fan. And then mint with sprinkles. There we go. And then hopefully you went on to do the strawberry ice cream. So we'll do strawberry down here. So strawberry with nuts. I like to do it in a particular order like this because when you then think, oh, have I got them all? It allows you to see that actually you have really included all of them. Okay, so I would definitely recommend that as a technique when you're trying to make a table for combinations. So strawberry with sprinkles. And then once you've got them all, you can think about how many combinations there were. Sprinkles, there we go. So let's have a little look. Let's see if we can count how many options there were. So here's the combination. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it was the same again, wasn't it? It was 4 combination of 4 options for ice cream, and then 3 options for toppings. And then if you multiply those numbers together, you've got the answer of 12. Okay, now this is your silver task for today. So there are 5 pairs of mittens and 2 scarves. Make a table to show the different combinations Misty could wear if she chose 1 pair of mittens and 1 scarf. How many different combinations did you find? So for example, I might start off here with red mittens. There we go. Or it already says mittens up there actually, so you might just do the color. So I might do red. There we go. And then I'm going to look at this scarf down here. I'm going to go striped. Oh, that says striped. Striped. There we go. And then I might think red again, because I've got another scarf option. So another red set of mittens, only this time with a spotty or a spotted. There we go. And then I would look at the other options. Pause the video here and give them a go. Okay, how did you get on? Okay, so here we go. Have a little look. So you probably would have ended up with a table like this, and there you should have found that there are 10 different combinations that Misty could wear of mittens and scarves. So let's just double check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. 10 different combinations. If you're ready for the gold challenge, let's move on. Okay, so here, Ella buys a drink and a snack. She says there are 8 different combinations I could choose. Do you agree? Show how you know. So pause the video here and see if you agree with Ella. Okay, so I had a little look at it and I decided that I do not agree with Ella. Ella thinks there are only 8 different combinations she could choose. So I disagree because there are 4 options for the snack and 4 options for the drink. So in that way, I needed to multiply 4 times 4 to equal 16. And then, just to be extra sure, I double checked it by making a table of combinations. So chocolate with juice, chocolate with pop, chocolate with milk, chocolate with water. So then I found all of those combinations. Then I looked at muffins and I did the same. I looked at cookies and then I looked at apple and I did the same with those. And I ended up with 16 different combinations of snack and drink I could have. How did you get on? Okay, let's try the platinum together. Okay, Jack and Alex are choosing food from a menu. There's the starters, the mains, and the desserts. Jack chooses a starter and a main. How many different combinations are there? Alex chooses a starter, a main, and a dessert. How many different combinations are there? Pause the video here and see if you can work out the answer to both of these questions. Okay, how did you get on? This was an interesting one. So if Jack chooses a starter and a main, there are 3 different options for the starter and 6 different options for the main. And when you multiply those together, you can find that there are 18 different combinations. For Alex was choosing a starter, a main, and a dessert. So for this one, we actually had to multiply 3 different numbers to work out all of the combinations. So how many different combinations were there? So I would need to do the 3 starters multiplied by the 6 mains, then multiplied by the 3 desserts. And all in all, I worked out there were 54 different combinations that Alex could have chosen. How did you get on? That's it for maths today. I hope you had a really, really good day, and we'll be back for more maths tomorrow.